Hello, everyone, and welcome to another exciting workshop hosted by us here at Circuit Stream. Thank you very much for joining us today for this amazing Build an AR Measuring Tape app workshop. We'll be getting started here shortly. I just want to give a few minutes to everyone to join in. As we're waiting for everyone to join in, could you guys please let me know if you are hearing me okay and seeing me okay? That would be amazing if you could confirm for me. Um, Perfect. Thank you, Bruno. Michelle, thank you very much. Amazing. Perfect. Well, again, thanks a lot for joining us. As we wait, I just want to do a few housekeeping items here. I want to make sure that you guys are aware of the chat section. Please feel free to throw in your LinkedIn profiles and make some connections. We're all like-minded people here. We're all interested in XR and all the potential and all the amazing things that has to offer. Secondly, at the bottom, there is a questions tab as well. If you have any questions throughout the session, please throw them in there at the end of the workshop. We will have a Q&A section, and I will bring those questions up one by one, and we'll get those answered for you guys. And then lastly, there is a polls tab as well. I will be throwing in 2 polls throughout the session. If you could answer those and participate in those, it would help us out greatly as we work to put more of these amazing workshops together for you guys. And also a reminder that this session will be recorded, and everyone who registered for the workshop will receive the recording as well as the material that is used or needed for this workshop through email. Now, without further ado, I don't want to take too much of your guys' time, so I'm just going to jump right in here with an introduction of myself. My name is Roham. I'm an enrollment advisor here at Circuit Stream with 7+ years of working in business development and customer service. And also in the past life, I was a semi-pro soccer player or football player for those of us not in North America. But again, that's a long time ago. I've since gained some COVID weight, as we all did. So those days are long behind me. And for today's workshop, we also have one of our best instructors for you guys. Mitchell is a film school graduate with 8+ years of Unity development experience. And on his free time, he plays the bass guitar in a punk rock band. And we actually have a team meeting or a team event coming up, and I may or may not be planning to put him on the spot for a little bit of a solo. We'll see. We'll see if I succeed. If I do, I'll be sure to share the videos with you guys in the next workshop. So stay tuned for that. Now, a little bit about who we are and our company in just a short minute, but I just wanted to give you guys a little bit of an agenda for today. We're going to spend 10 to 15 minutes in introductions, telling you a little bit about who we are as a company, and then we're going to spend around 45 minutes to 60 minutes on the technical session, as well as 10 minutes on some wrap up and share some resources with you guys. And then at last, we'll leave some time for the Q&A as well. Now, who are we? Who is Circuit Stream? Well, we're an education company founded back in 2015. Our founders noticed a gap in personalized training and education in the immersive technology or XR. And to date, we're proud to say that we've supported over 40,000 individuals in learning XR and in Unity. And these learners have taken part in our various workshops, such as the one we're hosting today, as well as our courses over the years. And this is, again, a milestone that we're really proud of. What we have at Circuit Stream, we're a global team of industry experts and passionate individuals about this technology. And as you can see on screen, we have team members and instructors all over the world, which helps us accommodate students across multiple time zones and geographies. Now, CircuitStream is also a Unity training and channel partner. Partners of Unity are approved based on their expertise, quality of education, and on the demonstrated success of their students. And for those of you who are unfamiliar with Unity, they have created one of the most extensive and robust development engines on the market, and I'll share more light. I'll shed more light on it very shortly. But I do want to mention that our instructors do maintain the highest level of certification offered by Unity. Now, we have an academic portfolio of free online workshops and webinars like the one today, and also a variety of courses that we offer, which are all designed to help students learn how to build virtual reality, augmented reality assets in Unity. And these courses are mainly for beginners, but we can help more intermediate and advanced students through our one-on-one sessions or team training offers as well. Now, if you are looking for XR specific training, look no further. We have our amazing XR development with Unity program for developers. And for those folks on the session today who are more design oriented, we also offer our interaction design and prototyping for XR program as well. And we've also recently launched our Unity Developer Bootcamp, which is an intensive 24-week live online instructor-led bootcamp to prepare you for a successful career in 3D development. And again, this is by far the most extensive program that we have ever offered, and we are proud to say that with the bootcamp, you guys do also get career services from industry experts as well. Now, one of the questions that we always get is, who have we worked with? Well, we've trained teams and professionals for some of the largest organizations in the world, such as Apple, Meta, Hershey's, and even the US Navy, just to name a few for you guys. We work with organizations large and small, right down to the individual learner. And I'm also proud to announce that as of this year, CircuitStream has been partnering with some of the world's most prestigious universities to offer our education programs. Our XR development with Unity program, as well as our interaction design and prototyping for XR program, is now offered by the continuing education departments of all the universities that you see on screen. And we are also launching new partnerships as well. And we are also working on offering our boot camp through these university partners as well. So stay tuned for those. Now, talking about Unity, what exactly is Unity? If you've seen this interface before, then you're most likely already familiar with the amazing engine. And if you've seen this muffin clicker game that we have on screen right now, then you've probably been through our C# scripting fundamentals course. But for those of you who aren't so familiar with Unity, Unity is a free development engine. It is a program that can be used to create both 2D and real-time 3D content, which would include augmented reality as well as virtual reality. And in our opinion, Unity is definitely the program most beginner-friendly if you're looking to start your journey into the XR world. Now, there are a few things we know about Unity, and then that one of the things is that it is without a doubt one of the biggest engines, if not the biggest engine in the world. As a matter of fact, over 60% of the world's AR and VR content is developed and created using Unity. And Unity is also responsible for an enormous share of the broader content and application market as well. Now, like anything, all these applications, all these awesome projects start with an idea. From there, you need to build your assets and bring them into Unity and create an immersive interaction using scripts in the C# programming language that Unity uses. Once you're happy with your build, you need to leverage a software development kit to ensure that your target device is compatible with your build. And once all that is done, all you have to do is render and publish your application. Now, enough about all those other learning opportunities. I know why we're all here today. Let's talk about what you're going to be learning today in this amazing workshop. You're going to be learning about how to start an AR project in Unity, how to use AR Foundation, how to use features like line render inside Unity, as well as some light scripting with Visual Studios. Okay, now let's get this show on the road. That'll conclude my portion of the presentation. Again, I'd like to remind everyone in the audience that we will be recording this session, and the recording as well as the course material will be sent to you guys via email. And one more thing, if the video quality is not amazing, don't worry. In the recording, it'll be great quality for you guys. Now, without further ado, Mitch, you're already on stage. Welcome. It's an honor and privilege to have you here today. I'll let you take it away. I'll step out and I'll come back a little bit later.
All right. Thank you. Thank you. Hi, everyone. Let's get my screen share going here. That one. There we go. So there should be a GitHub link you were sent. I see it's dropped in the chat too. So if you want to check that out, I went ahead and completed this whole measuring tape project ahead of time. And if you just download this zip file here, you should be able to open that up, extract it, and open up this folder with the Unity Hub. And this isn't necessary to follow along, by the way. This is just the actual completed project. If you want to see the finished product we're making today, with actually a couple of extra features that we're probably not going to get to. And check this out. And this is what it'll look like. It seems pretty bare bones, but basically the idea here is we're using a platform called AR Foundation, which allows us to create awesome AR experiences in Unity. And we're very simply, at a high level, to make this measuring tape, what we're doing is we're just placing 2 points in space and calculating the difference between those 2 points, or the distance between those 2 points, rather. And then we are just displaying that number on the screen, and that's it. That's our measuring tape. Actually, let me show you. I built it to my phone as well. Actually, I think this is kind of an early version, but shows the basic idea. Let's see. There we go. So there's my lovely floor, and we can see this plane on the ground that's being tracked, right? So basically anywhere on this plane, we can just tap to place this first point and tap to place another point, and we see this number. That's 0.63 meters we've measured out there. And see, AR Foundation works really well. We get this really high quality track. It's very usable, and really, again, there we go. Again, all we're doing is just placing 2 points in space and figuring out the distance between them. And to kind of, elaborate on that a little bit before we get started, in the Unity scripting documentation is a great reference if you want to figure out how to talk to any particular data type or component in Unity. So positions in Unity are represented by a Vector3, and Vector3s have this thing called Vector3 Distance. So all we need to do is place these 2 points, plug them in here, point A and point B, and then this does all the hard work for us, Vector3 Distance, and it spits that distance out between A and B. And yeah, that's all we are doing. That's all it takes to make this measuring tape. So let's get right into it. I'm going to make a new project and start from scratch here. The version doesn't matter so much, whichever version you have downloaded. I'm going with 2020.3 here. And I'm just going to make a regular 3D project. And I'll call this measure tape. We'll open that up, clean slate. The Unity version for the project is 2020.3.25. That's what I made this finished project in. So really any 2020.3 version would probably be fine, but if you want the exact version to open it up in, it's this one. All right. Got this blank project here. I'm going to assume actually you're not too familiar with the Unity interface here, but super quick overview. Unity is made up of these different windows, these different panels that all do different things. The sort of main ones we want to pay attention to here today are this hierarchy window, this hierarchy tab, the scene tab right here in the middle, the inspector, and the project window down here. And so this scene view is a 3D representation of our scene. So we can place objects and see them in 3D here, kind of like, you know, any other 3D software you've ever used. And this hierarchy is a different kind of representation of the same thing. So the hierarchy is it's a list view of all of the things that currently exist in our scene. We can see right now our scene just contains a main camera, which we're going to have to delete actually, and a directional light. And when we click on one of these game objects here, these are called, we can see something change. The inspector populates with a bunch of components. These are all called. This is a transform component, the light component. The inspector populates here to show us all of the different components that make up this game object. So all that makes this game object a camera is that it has this camera component here. And this has a directional or a light component. And we can actually make our own components. I just switched over to the finished product here. We can make our own components like this tape manager here. When we write C# scripts, they can actually be added to game objects to add functionality to the game objects. So yeah, anything here in our hierarchy is totally customizable, and we can write our own scripts to sort of in a modular way add on functionality. So we're going to be making the script called the tape manager today. And this is kind of where the bulk of our work is going to be. And basically what this does is it refers to these two tape points here that I just have sitting in the scene at the start. And these are the two things that we're placing in 3D with the with our AR foundation, with our Raycast. And there's a reticle, and there's some reticle is like a little marker to show us where we're pointing. So there's that, and there's some text to actually change and display the amount of distance between these two tape points. So that's what we're going to be recreating. Hold on, there we go. I'm on a Mac today. That's not particularly important, but I just want to be able to build to my iPhone. But if you're on Windows and want to build to Android, that's perfectly fine too. It's not going to change much about this process. Let's get our project ready for AR. So we'll go into the package manager up here by going to Window and Package Manager. And there's a couple of packages we need to import to be able to work with AR Foundation. You can see I have to sign in here. So I'm going to sign in with my Unity account off screen here. All right. So you can see I have a whole bunch of assets, 400 assets. So I've been doing this for a while, but I'm going to move out of the My Assets section here and going to head over to the Unity registry. And in the Unity registry, we can find some packages that are made by Unity. And you can kind of think of these as modules, like add-ons for Unity to make some functionality happen that isn't built into the editor. Because if they built all this stuff in, it'd be pretty bloated, right? So we're going to import something called XR plugin management, which actually manages all of our XR plugins, like AR Foundation. So we have that imported. I'm going to scroll up here. There's a few more. We want AR Foundation. That's that special sauce I've been talking about that allows us to easily make AR applications. So I'll import that guy. And then next, we're going to want to import either AR Kit or AR Core, depending on if you're building to an iOS device. You're going to want to bring in AR Kit. If you're building for AR Core, then you'll want to bring in the AR Core add-on. I'm just going to do AR Kit for this one, actually. But this isn't going to change much if you do one or the other or both. It really just depends on what you want to build to. All right. And so we have those packages imported now. And we can tell that we're ready to go and ready to start working in with AR Foundation. Is when we right click, we have this little XR area here, right? So before we didn't have that. When we right click in the hierarchy, this brings up a list of default game objects that we can make. So kind of like preset little template things. So we can make like, our primitive cubes and such here. But we're not gonna make a cube today. We'll just make our measuring tape. If we go to XR and convert main camera to XR rig, it's going to automatically delete this camera and make a camera offset. Oh, wrong thing. We want to delete the camera still, but we want to make an AR session and an AR session origin. What am I thinking? So we'll make an AR session first. And an AR session is kind of like it's like the timekeeper. It's sort of the heart of our augmented reality experience. It's what everything sort of refers to. This is like the AR god here. And we need AR session to keep track of everything. And we also need to make an AR session origin. And our AR session origin is like our augmented reality equivalent of a camera. It does actually have a camera in there as well. But yeah, we can't actually see this in action. But as we move our phone around, this AR session origin is going to move around with our phone in this virtual world here. All right. So we have our AR session origin with its AR session origin component. We have our AR session game object as well that we made just by right-clicking and going to XR, make the origin, make the session. And yeah, so a couple of other housekeeping things before we actually get started here. Want to go to build settings. And this is where we can choose our build platform. So this is where we can pick what we want this project to actually be output to. So right now it's on PC, Mac, and Linux standalone. So that's like we're making something that just plays back on a PC or a Mac, like a desktop. They might as well call this desktop. And these are our two mobile options, iOS and Android. Since we're working with AR Foundation actually only will work on iOS or Android. So I'm going to pick iOS and switch platform here. And this is probably going to actually take a minute, but it is it's going to be necessary at some point if we want to build this. Oh, that was fast. All right. Player settings here in the bottom left is where we want to go next now that we have our project changed over to either iOS or Android. So we'll go to player settings. Here we can set things like our company name. I'll put Mitch Inc. Seems to have a nice ring to it. And we will scroll down here. In our other settings, there's a couple of things that we need to do here to actually build this. Requires ARKit support. We need that checkbox. This is just for iOS, by the way. For Android, I'll show you the settings for that as well. Actually, that's all we need for iOS. Yeah. And on Android, what you want to do, oh, that doesn't look good. On Android, we need to do a couple of more things if you happen to be building to Android today. We need to remove the Vulkan graphics API here because that's actually not compatible with AR. So we'll get rid of that and keep scrolling down. And we need to set the minimum API level here to 28, level 28. And one other thing, we'll change this scripting backend here to IL to C++ here. And we'll change the target architecture to ARM64. All right, so that's our build settings. So that's all good to go. Next, we want to enable our XR plugins. So in our XR plugin management section here of project settings, if we're on iOS, we want to just check off this ARKit here. And that just enables ARKit, which is the native SDK for creating AR experiences on iOS. We don't need to deal with it directly, thankfully. AR Foundation handles that for us. And same with AR Core, which is the Android kind of equivalent to ARKit. The beauty of AR Foundation is that we can just make this application once in Unity using AR Foundation, and it will natively use ARKit and AR Core, but we don't have to talk to those things directly. We just deal with AR Foundation, and it abstracts those things away from us. All right, so at this point, we have all of our settings ready to go. We can actually start building our application. There's a couple of things we want to add to our AR session origin. Right off the bat, I know we're going to want the AR Raycast Manager. And this is a very special component of AR Foundation. And what this does is it allows you to create a raycast that works with AR. If you don't know what a raycast is, in a game engine, a raycast is kind of like an invisible laser pointer. You could imagine. So we can decide where to shoot this invisible laser pointer out from, and when that laser pointer hits something, then we can get information about that thing that it's hit. So in the context of our measuring tape, got our phone here, right? We're shooting out an invisible laser from our phone to place that first tape point and then place our second tape point, and then we get the distance between the two. And And that's it. That's our whole application, really. In my demo, you might have seen that the application was rendering this plane on the ground. So we can see this representation of the plane on the ground, all those dots. And that's done with this AR Plane Manager here. AR Plane Manager. So I'm going to add that component to our AR Session Origin. And our AR Plane Manager, it wants a plane prefab to use here. So we can give it one. In our project window down here, this project window is a representation of our project on our hard drive. So if we right-click one of these files, we can go to Reveal in Finder or Show in Explorer, and it actually shows us the same files on our hard drive. So scenes and XR are the same thing as scenes and XR. So this isn't that relevant to this particular project, but when you drag and drop something into this project area or into this this folder here, that's essentially the same thing. You're just changing the same files in different ways. And it seems like a sidetrack, but I just wanted to give some context to what we're doing here when we create a file. So we're creating an actual file here, an asset, and we want to create, where is it? We want to create a plane prefab. There we go. We right-click the hierarchy, and there's an AR default plane. So we'll make an AR default plane. And I thought that was something you did down there. Okay, never mind. And we can just drag this AR default plane into our plane prefab here. And now it'll be able to actually show our planes as it scans them. And it says detection mode. We can choose if we want horizontal planes or vertical planes or both. We'll just keep it on everything so it can do both. That's fine. All right, so next, let's actually make our own custom component, our tape manager. So I'm going to make our tape manager script, and we can very quickly make a script by typing in the name here, clicking new script, tape manager, just saying create and add. And it should open up Visual Studio here. There we are. Well, that doesn't look good. I think we'll be okay though. And we're greeted with this blank tape manager script. This is, hold on, I have it somewhere over here. This is what the script looks like, the finished script in the GitHub link that I sent. So when you open that project, you should already have this script in it. And basically, we're not going to cover all of this today. This has some extra features in it, actually. Like I might have went overboard here, and I made this unit conversion thing where it you can pick if you want the unit to be meters or centimeters or inches or feet, and just a couple other things in here that you can look at. But we're going to make a more bare bones version, sort of based on this today, just because of time. And so yeah, that's what the script you can download will look like. And we're just going to start, remaking a bare bones version from scratch. So first thing we want to do at the top here, outside of our class. So this area up here is where we can import special special features. I'll call them. Well, this is actually namespaces up here. So if we want to to deal with AR Foundation through code, we have to import our AR Foundation namespace here to be able to have access to all of that that data, those classes. So we want to say using Unity engine dot xr dot a. I'm not getting autocomplete here. That's not good. Let me figure that out, because this won't be fun without autocomplete. No, preferences, right? So when this happens, first thing I look at is I go to preferences, external tools. I'm looking at Visual Studio for Mac is set to my external script editor, so that's good, because that's what I'm using here, Visual Studio for Mac. Let's try regenerate project files. This button sometimes fixes this this issue, and it doesn't really look like it is. Load operation failed. Let's close Visual Studio. We'll just quit, and we'll try this again. Open up our tape manager. Solution loaded. Better. Okay. I think we're in business now. All it took was a restart. Now you can see this this autocomplete. You may hear this referred to as IntelliSense sometimes pop up. And this is yeah, sort of one of the dirty secrets about coding, is that you're not just tapping away at a keyboard like a superhero. Your computer is actually doing a lot of the work here. So when we type in Unity engine and press the dot, we get a list of all of the things that we can import here. We want xr dot AR Foundation, because we're dealing with AR Foundation. We want to be able to talk to those components. And we're also going to need something called AR subsystems. So we'll import that as well. And we're sort of off to the races here. So first, at the top of our class, I'm going to make a public array of game objects. So we'll make public array of game objects. I'm going to call this tape points. I'll save that. And what this basically does is this, because it's public, this is going to show up in the inspector here. Watch it pop up. There you go. So we got this tape points drop down now. So this is almost like a list of game objects that we can make now. So if we set this length here to 2, now we have these 2 empty fields for game objects that we can then populate and then refer to in our code. So I'm going to make 2 tape points, which are just going to be empty spheres. There's nothing special about these, and fill them in there. So I'll make a sphere here. I'll call this tape point 1, and I'm going to make the sphere a bit smaller. With our transform component, we can make the scale a bit smaller. 0.1. This is in meters, by the way, so it'll be what's that, a 10 centimeters. And we'll make a tape point 2 and just have it in the same place. And these don't need to be enabled by default, so I'll just disable this. AR session origin, and now we can drag these game objects into here. And now, when we talk about tape point element 0, it's referring to this game object in particular. And when we refer to tape point element 1, it's talking about this game object in particular. So that means we can say place or move tape point 1 to over here and move tape point 2 to over here in our code. And that's how our scripts kind of get linked up to these visual representations of things in our editor. So by making something public or making it serializable, it shows up here in our editor. So we got those tape points. I think maybe a good way to start here would let's just calculate the distance between those 2 points. So if we make a public float up here, which we're probably not going to keep, but I just want to demonstrate, distance between points, we'll make it 0 by default. In our update loop here, which happens every frame, as opposed to our start loop, which just happens once, everything we put in here is going to just keep on getting run recursively every single frame. So we can set our distance between points every frame equal to, remember I was talking about that fancy Vector3 distance, right? So Vector3 distance takes in 2 Vector3s, A and B, and it returns a float. Since this is a float, we're going to be able to set this to the result of Vector3 distance, and we'll give it an A and a B. Our A is going to be tape point, the first element, which is the 0th element, and then tape points 1. But these are actually game objects, so we have to say dot transform to get the transform component of them, and then dot position. So yeah, position is a Vector3. So what we're doing here is our tape point 0, which is actually this, our tape point 1 here. We're talking to the transform component with the dot there, and then we're getting the position with another dot. So our transform dot position. So we have our first tape point, and we have our second tape point. And now our distance between points is going to update every single frame, and it's going to show us in the inspector. Remember, because this is public, so it's going to show up in the inspector. It's going to show us the distance between those 2 points. As long as they're enabled. Oops. So if we hit the play button, we actually run our game, and that update loop starts getting updated all the time. But check this out. In our tape manager, we have our tape points, public tape points array. We also have our distance between points here, this float. And watch what happens as we move these different tape points around. That distance changes. So that's a pretty good portion of our measuring tape already done just with 1 line of code. Isn't that something? We're already calculating the distance between these 2 objects. Now, all we really need to do is just place these 2 objects, and then we have ourselves a rudimentary measuring tape. Right? See that distance between points moving? All right. Oh, my inspector is locked there. That's what was going on. Okay. So let's continue here and actually place these tape points in AR, and then we can just keep this distance between points, if we want. And then we just need to display it through text. So to be able to place these in AR, we want to talk to our AR Raycast Manager component, which is what's actually shooting out that invisible laser pointer. So we want to make a variable of the type AR Raycast Manager. And this is part of our AR Foundation namespace right here. That's why we needed to import that. And we can just call this AR Raycast Manager. We have to name it something here. We'll just call it that. That's fine. And then in our start method, remember this only runs once. We want to hook this up to our AR Raycast Manager. So we can say this AR Raycast Manager variable is equal to this special thing called getComponent, which looks on this game object. And for whatever type we give it, it'll be like, say we want it to look for an AR Raycast Manager. It'll look through its friends here and be like, hey, you're an AR Raycast Manager. There you go. You get to fill in that. So if we just get component AR Raycast Manager here, then that's going to be hooked up. So now when we are referring to our AR Raycast Manager, we're talking about this AR Raycast Manager in particular. Alternatively, you can make it public and do the same thing that we did for these other two. But, you know, this works as well, and you don't have to drag and drop anything in the editor. That's the difference, really. So, in our update loop here, we are going to start actually placing this point in AR. So we want to do something called a Raycast, like I was saying. So our AR Raycast Manager, sorry, not that, our variable AR Raycast Manager, right? If we press the dot on that, it actually has this Raycast method. So a method is like a method's like a machine, right? We can put things into this and it can spit a result out. For example, Vector3 Distance is a method. We give it two Vector3s and it returns this float, this distance between points. So our Raycast, we have to give it a whole bunch of things for it to work, right? Actually, there's a couple of ways to use it. You can flip through the different ways here. We're going to go for this one. So we're going to give it a screen point, which is where it's going to shoot out from. And then we have to give it a place to put the hit results. So what it hits has to go in this list of AR Raycast hits. And then we give it a trackable type. So that seems simple enough. So for this first one, the screen point, it wants a vector2. So we can give it a new vector2. And then we need to specify what is our vector2. And we're going to give it screen, which gives us access to information about the display of the device that this is running on. So we want to do screen dot width divided by 2 for our first number, for our x-axis here. And then for our y-axis, we want to do screen dot height divided by 2. And this will give us the center of the screen, right? Half of the width, half of the height, that'll be right in the center. That's where we want our laser pointer to come from. Okay, so that's our first thing we needed to give it here, screen point. Next, we need to give it this list, a place to put this list of AR Raycast hits that this is going to be spitting out, hit results. So that we have to do something a little different. We're going to make a new list of AR Raycast hits. And we can just call this hits. And this is kind of like weird, but the syntax for lists is this. Basically say, we're making a list of the type AR Raycast hits. It's named hits, and it's equal to a new list of AR Raycast hits. Seems a little bit convoluted, but that's how it works. And then we just want to put hits into there. And that satisfies that second requirement. And then we need to give it a trackable type. So for that, we can say trackable type, and we'll give it this one, plain within polygon. That one just seems to work the most reliably for me. You can also try putting just planes. That's also an option. Planes. But that one, I don't know. It was a little more sketchy when I was testing it out. It would like place the tape points in the air sometimes. So I'm just going to go with plain with polygon, within polygon, which is a little more picky. All right. Let's get through this here. So our hits. If our Raycast hits one of these planes on this frame, it's going to be added to this list of hits. So we want to check if something is in that list. So if hits dot count is greater than 0, meaning if our Raycast hits something, if our laser pointer is hitting the floor or our table or something that's a plane, in that case, we want to do some stuff, right? If we're hitting something, we want to do some stuff. And the first thing that we want to do is we want to turn on that reticle so we can see what we're actually pointing at. And we haven't done that yet. So I'll make a public game object for reticle. And we haven't even made a reticle here yet. So I'll do that really quick. We'll make not a capsule, make a cylinder. The little puck type thing here. And I'll just make it pretty small. And set its position to the origin here, just to the middle. And this cylinder will be our reticle. Again, nothing special about it. It's just a normal mesh. It's just a normal primitive, just like our tape point. Right? Let me just disable all these. And we'll hook up the reticle here. So now when we refer to reticle in our script, it is talking about, bam, this game object in particular. So if it's hitting something, if hits.count is greater than 0, the first thing we want to do is we want to set the reticle dot transform a position. We want to set that equal to our first hit position. To get a position of an AR Raycast hit, when we press the dot, you can see there isn't a position, but there's this thing called pose. So we can look into pose, and that's how we get the position of a Raycast hit. So reticle will be set to the same position as what we hit on this frame, and it'll also be set to the rotation. So that way, if we're aiming at a wall, then it'll rotate the reticle so it'll stay flat on the wall. So that's what we're doing here. And then I think we want to start actually figuring out how to place our tape points now. So we're going to use something called input.touchCount in order to do that. So if input.touchCount is greater than 0, so if the user is touching the screen, then we want to do some stuff, right? And also if input.getTouch are 0th touch, if our touch phase is just beginning, so if we're at the beginning of our touch, then we want to spawn a tape point, right? And this touch phase part is important because we don't want it to keep placing them as long as we're holding down our thumb on the screen, right? We only want this to happen when the finger starts to touch the screen. So we'll do touch phase began here. And in that case, we want to place a tape point. This is called a comment. It's just to put a note to ourselves, right? Doesn't actually do anything. Yeah, so in order to know which tape point to actually place here, we're actually going to have to keep track of that up here with an int. So we'll make a new int and we'll call this current tape point. We'll set that equal to 0. So this is the amount of tape points that we've placed, right? Because if we're at 0 here, then when the user touches the screen, we want to place the first tape point. If this is at 1, then we want to place the second tape point. And if this is at 2, then we don't want to place any more tape points. We already have our measuring tape placed, right? So we'll place a tape point. If current tape point is less than 2, then place a tape point. So we're adding yet another condition in there. We only want to place a tape point if the screen's being touched, if the phase of the touch is at the start, and if there's less than 2 tape points on the screen. Place a tape point. Then, we want to actually place a tape point in that case. So let's actually, we'll break out the placement into another method here. So outside of our update method and our start method, I'm going to make something called place point. So public void, we'll call this place point. And this place point method, remember I was saying methods are kind of like machines. They take in data and they can output data. This is what we're going to want it to take in. We want to take in a vector3 for point position. And then we want it to take in an int for point index. And then here's what we want to actually do with that. So our tape point that's at our point index, we want to set it to active. So we'll set it active to true. So that's basically going to enable it here so then we can see it. That's what setting it to active is. This is the active button. So when we place a point, we want to set the appropriate point, so the tape point at point index, to true. And then our tape points at point index, we want to set its transform.position equal to our point position that we get passed in here. And then all this is done. Our current tape point, we just want to make it equal to current tape point plus 1. So it goes up by 1 when all this is done. So if current tape point is less than 2, or I mean, yeah, it's less than 2, then in that case, we want to place point. So we're going to run this method, and we need to give it some parameters. So we said down here, we want to give it a point position and a point index. So for point position, we can actually give it that that hits 0.pose.position, right? And then for point index, we just want to give it current tape point, which is going to be 0 our first time we do it, but that's going to keep incrementing because we increment it down here. So place point like that. So we'll place a point and then increment it and place the next point. And then still within our began phase here, I'm going to make a new Boolean up here at the top. And I'm just going to make this cool. I'm going to call it placement enabled. And I'm going to make it true at the start. And basically, this is just going to be a way for us to limit how often we can place these points. So after a certain point, we want to just flip that to false, so you can't keep on placing, these points, because that would create some weird errors. Yeah, place a tape point. Yeah. So if we place one, then we'll make placement enabled equal to false. And then else if input dot touch count is greater than 0 and our phase is ended, so at the end of the phase, then we can enable placement again, right? Just so we're only placing the point once. And then finally here, for sort of bare bones measuring tape version, how about we get some text on the screen here? So I think that'll be the quickest way to do this. We're going to make some text, and that'll just display what our measuring tape result is here. So let's go to UI, and we'll make a text, make a text mesh pro text here. We want to import TMP essentials. Go to 2D up here. And we can see we got our text. I'm going to change this to be like a portrait iPhone. And I'm just going to place the text at the bottom of the screen here. And I'll make it say 0 meters. And there we go. And this will be our text that we edit, and that'll tell us what our measurement is. Right? So we need to make a field here so we can talk to that text, just like we have with our reticle and our tape points. So let's just fly up here. And to talk to a text mesh pro text, we have to say using TM Pro. And we want to make a public. Wait, what is it again? Make a public TMP public TMP underscore text. I know you're in there. There we go. We'll call this display text. And this is just, what we're going to want to modify to say our measurement. So when we calculate our distance here at the end of our update loop, after we do that, we can say our display text is dot text. Display text dot text. So that's our our actual text box here. Right? This is the dot text. We want to say that is equal to distance between points dot to string. That will make it into a string and let us see it there. Oops, I think I made a breakpoint here. There we go. Okay, let's see. We'll kind of partially test this and just see if this number changes when we go into play mode and start moving around our tape points. It should. We're moving our tape point. Got to enable the other one probably. Move that tape point, and we have an error. Object reference not set to an instance of an object. And if you're as forgetful as me, you're going to see this hundreds of times throughout your Unity development career. And basically what that means is that this object is not set to anything. It's not set to our text. And there we go. So when you forget to fill something in there, it'll complain. Unity don't like that. All right. Now you can see as we move our tape point, that number changes. All right, one last final touch is we want to have a line that gets rendered between our two tape points. So it kind of looks a bit like a tape measure, as you can see here. And we can do this with something called a line renderer. So let's do that. We'll make a line here by going to 3D or no, not 3D object. What is it? Effects, line, and over here, by default, it puts the line at this weird, these two positions, right? So it has a start and an end, a 0 and a 1. And the first position is at 0, 0, 0, so our origin, which is right here. And our second position, so position 1, just has its z set to 1. So that's 1 meter out here. What we want to do is modify these settings here, these positions, to change depending on where our tape points are. So if we've placed 2 tape points, then in that case, we should be able to, we should be able to just put those positions onto this line renderer. So yet again, we'll make another variable up here. This time we're going to make a public line renderer. We'll call this line. Save our script. And where are we? We can feed it this line here. So now we can talk to it. And what we want to say is if current tape point is greater than, so greater than 1, I think, or would it be? Yeah, that should be fine. Because if it's greater than 1, then there's definitely going to be 2 tape points down. So if it's greater than 1, then line dot enabled equals true. So we'll enable it so it gets drawn. But we also want to set line set position. We want to set the position of the first part of the line. We want to set that to our tape point 0 dot transform dot position, and we want to set so that's setting our first part of the line, and then we want to set the second. So I'm getting my Mac and Windows shortcuts confused here. And we want to set our second part of the line to tape point 1. And there we go. I'll build this out and we'll see. I'm just going to disable the line. Unless I missed some critical part here, I think that's our bare bones tape measure ready to go. So I'll just make an iOS build here. Tape iOS build. And let that build out. Probably should have went to build and run. All right. So I'm going to open up Xcode here because I'm building to an iPhone. On Android, you just have to pick your run device and hit build and run, and it's quite a bit easier. But for iOS, we have to, we have to go through Apple's whole system here and open up Xcode. Let's see, open a project or file. Bear with me. All right, so we're here in Xcode, and what Unity does is it actually spits out a complete Xcode project. And I'm just going to build this to my iPad here. So I have my iPad hooked up. I have, for this you have to go and make an Apple developer account and add your Apple ID here to this account section. And under signing and capabilities, I'm just going to say automatically manage signing. Set the team to my name here. It's complaining about a certificate, so I'm just going to revoke and let it create a new one. And should be able to build it here to my iPad. It's building. Building, building, building. Password a few times here. Hey, installing to iPad. Let's see. Let's check this out. Might work, might not. That's the magic. That's the fun. Okay. Oh, I see our plane. I see our number at the bottom. I see one tape point, and I see 2 tape points. 0.2 meters. There we go. That's our rudimentary measuring tape. The only thing I didn't do was I should have enabled the reticle, because I can't see the reticle. But other than that, that's a measuring tape. All right. And once again, if you wanted to run this on Android and let's see. If you wanted to make this work on Android, you just have to switch the platform here, which I'll do. You know what? I think we're doing really good for time here. So let's Got an Android phone here. Just plugging in my Android phone. Have to allow USB debugging on here. And we can just pick this run device, build and run, and we'll name it tape measure. And getting some Android-y errors here. Mono input outlet layer. Yeah, I don't know about that. I think I've been having some problems with Android in this, so I'm not using a admin account on this Mac. Yeah, how did you install the app in iOS tablet? Yeah, so that was all through Xcode. So that's a whole different system than Android. But yeah, the only thing I really missed was we weren't turning on this reticle anywhere in the code. But if we just flip this on, hold on, let me switch back to iOS here. So obviously Android doesn't want to cooperate with me right now. You can just build and run. By saying append release, it's a little bit quicker. It just it doesn't rebuild the whole Xcode project. It just changes the parts that you changed. It's a little more efficient. And yeah, I have my iPad actually plugged in with a cable, but you could do it wirelessly, and it'll show up here as well. I think you just have to set that up in the preferences here. Oops. It seems like it opened a new one. I see a question. My camera is not enabled after after the app is installed on iPhone, and I think you might have just missed a really small step in the player settings here. You might have missed requires ARKit support. If you don't have that checked, then you're just going to get a black screen. So I imagine that's probably it. Got that checked, eh? Did it come up with a pop-up asking you about if you want to enable the camera for AR support? Or did that pop-up not even come up? Not really. The only other thing that comes to mind then is you might not have this checkbox ticked, XR plugin management, iOS ARKit. Yeah, I have the text in the screen, but just the black screen. That makes sense. I mean, that means that for whatever reason, ARKit isn't being initialized. So that makes me think it's this XR plugin management doesn't have ARKit here. Ah, there you go. No problem. Unlock my iPad. Share the screen. That's what I'm talking about. Now we have the reticle. We can go tap and tap. There we go. All right. And yeah, that's about it. I know that's yeah, it was pretty speedy at points there, making that script. But if you yeah, go back and follow the video, I think that'll be useful to have, as well as the GitHub with the finished bigger script I did. That one actually has yeah, some pretty cool stuff in it. It works a little bit better than this bare bones version I made, but of course we don't have time to go through all of it. That was a lot of fun. Thanks for attending, everyone.
Alrighty. Thank you very much, Mitchell. That was a great presentation. I'm sure everyone learned a lot. I was trying to follow myself as well. I'm sure the recording will come in handy, and that'll actually on the topic of recording. Again, as a reminder, the session is recorded, so everyone will get a copy of the recording as well as the material that you have to download as well. I can see we've had many questions come through as you were doing the workshops, so I'm just going to take a few more minutes before we re-invite Mitchell back up on stage. I'm gonna give him a break to grab a glass of water, and then we'll have him back up so he can answer all your questions. Now, finally, if everyone could just navigate to the poll section, I am going to drop in a poll on a scale of 0 to 10. How likely are you to recommend this webinar or this workshop to your friends, colleagues? It really helps us improve our content. You know, the more we hear from you guys, the more we can improve and change our workshops and host more of these awesome workshops for you guys. Now, I also wanted to run through a bit of our course options and information as well. If you enjoyed today's workshop, we'd love to have you continue your learning journey with us. You know, my favorite part of hosting these workshops, other than, you know, learning something new and doing some awesome things on Unity, is to show off some of the amazing work that our students have been able to create over the years, whether it's creating a unique Unity scene, building interactive AR experiences with Vuforia, or scripting mind-blowing experiences as well. Ultimately, we love to help our students along their learning path and help them to achieve amazing things. And on screen, you see just a few examples of students who have gone to carve out a career in XR after learning with Circuit Stream. A lot of these students, they didn't have any previous knowledge. They were complete beginners. So if you are a beginner, please have no fear. Our courses and our programs are beginner friendly. Now, I would like to introduce you to our fairly new self-paced course for app development. This is a 6-hour video course that allows you to move at your own pace, and it'll provide an in-depth guide on how to build your first app for your portfolio. We also have our C# scripting fundamentals course, which is a 4-week on-demand course focusing on C# coding for those interested in diving a little bit deeper into the language. And then finally, we'll get into our beginner-friendly 10-week live instructor-led XR development with Unity program. In this program, you'll focus on making AR and VR applications in Unity with 3 hours of instruction per week, lifetime access to both the class recordings as well as the 5 office hours that we hold per week. And with the plus package of this program, you'll also have 10 hours of one-on-one time with our experts that can be used for both personal projects or the course material, whatever the case may be, the 10 hours are yours to use. And this course is also available through us directly with a cohort coming up on July 26th, as well as our university partners. As you can see, University of British Columbia, they also have a cohort on July 26th. Same with University of Toronto, as well as University of San Diego and UC Riverside. All cohorts are on July 26th for this particular program as well. And then we also have our beginner-friendly interaction design and prototyping for XR program. This is also 10 weeks long, instructor-led, live and online. And the main focus of this program is designing experiences for AR and VR versus web and mobile applications. You know, much like the XR development program, you'll have 3 hours of live instruction per week, access to class recordings as well as the office hours that we have every week, and you'll have access to those for life. And through the plus package, you'll also get 10 hours of one-on-one time as well. This course is also available through us directly with the next cohort coming up on July 13th. Similarly with the XR development course, the University of British Columbia is offering a cohort on July 13th, as well as University of Toronto, University of San Diego, as well as UC Riverside. Um, Now, the main thing, the big guy, as we like to call it, our amazing Unity Developer Bootcamp, which will prepare you for a 3D development career. This helps you build a portfolio of 10 plus projects, and our one-on-one career services helps ensure you make the right connections in the industry and helps you make the best first impression on potential employers. The boot camp is only available through Circuit Stream directly, and the next upcoming cohort for this amazing program is on October 11th. Now, beyond the lessons themselves, we've also created a robust community of XR learners and just individuals who are passionate about this industry. All of our students and alumni get lifetime access to all of the material and recordings from their classes, in addition to lifetime access to all of the perks associated with our community. Our student experience coordinators, Lucy and Arki, run all kinds of awesome events and are dedicated to support our students and alumni. And, you know, they facilitate extra office hours, support group, demo days, and so much more. Now, like I mentioned, for both of our 10-week programs, there is no experience required, so beginners have no fear. Okay, I'm sure many of you are wondering about tuition prices for our courses, so I'm just going to take a minute to discuss the finances involved. We offer two different packages, as I mentioned, for both our XR development with Unity program, as well as our interaction design and prototyping for XR program. And our self-paced courses are sold individually. Now, the starter package for both the XR Dev as well as the XR Design program, they start at $3,950 US, and the Plus package, which includes the 10-week program of your choice, the C# scripting fundamentals on demand course, as well as 10 hours of one-on-one time with our experts, comes in at $4,950 US. A quick word on the university tuition: the starter and the plus packages are sold for the same prices as what you see on screen now. However, our Canadian university partners process their tuition in Canadian dollars, but to access that pricing, you must live in the province where the partner is located. So just keep that in mind. And for our boot camp, The regular tuition is $14,995 US. There is an admissions process. There is an aptitude test that you do have to take. So there is a little bit of required experience with Unity involved in order to be able to apply for the boot camp. If you require more information, please don't hesitate to reach out to us. We'll be more than happy to assist you and walk you through the process. Now, on the topic of finance, we do offer payment plans for our boot camp, as well as our 10-week courses, starter or plus package. So if you would prefer not to pay all up front and at once, you're more than welcome to take advantage of any of these plans. For our international students, we offer a 3, 6, and a 12-month financing option. And for students who are located in the U.S. and are citizens of U.S., we do work with an external financing partner called Climb, and loans are available for up to 5 years. Again, on screen, you will see our admissions team: Tyler, Leanne, myself, Shoshana, Stella, Brendan, Christina, and Robin. If you have any questions, please feel free to reach out to us. We're a little bit different than other companies in that we're extremely involved in the before, during, and after part of your registration process. We're here to help answer any questions you may have about financials, your learning or career goals, and about Unity or VR and AR devices, and so on. You can reach out to us directly through our website or through a call or email if you've already connected with one of us previously. Now, feel free to head over to the learning page on our website or any of our affiliated partner websites to learn more about each of the courses, to download a syllabus, or to submit an application to enroll, so that a member of our admissions team knows to reach out to you. Amazing. Thank you very much, guys, for sticking around. That'll wrap up the presentation for today. At this point, I'd like to invite Mitch back up on stage so we can get started with your questions. Again, I do see that there's a lot of questions here. Perfect. There he is. All right. There's a lot of questions here.
Yeah.
Let's see. Start.
Uh, well, so Tom's asking, are goggles not required for the XR experiences? Phones are valid for training and fun for experimental. I would say it depends on the particular application. I mean, for AR experiences, phones are really popular because they're very capable of being able to track an environment and, augment the environment, place things on top of it. And everyone has a phone. So I think, I don't know, they're not the same experience as using something like a Microsoft HoloLens, just because they're not hands-free. But phones can be very powerful for AR in particular. For VR, they don't have the tracking capability for the device themselves that something like an Oculus Quest 2 would have, and they don't have the display capability. So for virtual reality, phones aren't that capable. But for AR experiences, I think for sure, as long as they don't have to be head mounted for some reason, then that's the strength of a HoloLens.
Perfect. Let's
Are
see. And
XR
then
devices provided to students for the duration of the course? No.
no, the XR devices are not provided for the duration of the program. Again, we usually recommend the Oculus Quest 2, which is not an overly expensive headset. Just keep in mind, with our programs, you don't need the top of the line kind of headsets, but they do not come, they're not provided to students for the duration of the programs. Perfect. And then let's see here.
Yeah, so how
All
confident
right.
and sure are you to place the two take points in the same AR scene based on the topology of the AR scene? That intrigued me a lot. Well, topology of the AR scene. So I think you're referring to the environment that I'm currently in, right? So just putting the two tape points on the floor like that in this particular lighting condition. I have a big window right here, so the phone can clearly see a bunch of points on this floor, and the floor isn't like plain white. It has a lot of contrast to it, so there's lots of tracking points. So I was, pretty confident that on my phone and on the iPad, which has a worse camera too, it's gonna be fine. I could place points on the floor. If I had to put those tape points on this big plain white wall right here, then I wouldn't be so confident, right? It might not work so well.
Perfect. Thank you. And then let's see. The next one is there a job board for grads? If so, can you provide a link? In terms of a job board, I know that our team is working on that specifically because we are offering the career services with our boot camp. Keep in mind the last cohort that we just were in right now as we speak was the first ever cohort for the boot camp. So it is a work in progress, the document, but I can definitely take this offline, Tom. I will reach out to you personally and provide some information in that regard. And then I know, again, our team is working on that, so I'm sure that it will be published on our website soon. And then let's see here. There's a few more questions. This one's an interesting one. I am not sure about this, Mitchell. Maybe you would have a
I,
better idea.
I don't have insight either. I'm
I
not sure.
I mean, it's in the millions. I would imagine for sure it's in the millions.
Like Unity developers, but specifically XR Unity developers. I'm not sure, honestly.
That's an interesting question. That's a very interesting question. I'm gonna research that personally offline. Let's see, and then all right. I believe that is it for the questions. There was another one that you answered while you were doing the live session from Surav, who said my camera is not enabled after the
Mm-hmm.
app is installed in iPhone. So,
We figure that one
um,
out.
yeah, we did figure that one out. All right. Looks like that is it for the questions. Again, thank you very much, everyone, for joining us today. Thank you, Mitchell, for your time and for the amazing workshop. We love having you guys over for our workshops. And again, if there are any questions that come up after the workshop and after this session, don't hesitate to reach out to one of us on the admissions team, and we'll be able to get some answers for you guys. Wherever you are in the world, thank you again. Have a good morning, good afternoon, or good evening. The rest of the day, have fun. Thank you very much, guys.
Thanks, Ro. Thanks, everyone.